Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I will first introduce Ramesh. Ramesh is an entrepreneur, researcher, and also educator. He is a fellow of IHB, ASM, and many other organizations, and distinguished professor from University of California, Irvine. And Ramesh has founded multiple companies, and he's still running some companies now. And today he will show us the latest work. Ramesh.
Thank you very much. What I am going to discuss with you today is something that I am very, very excited about. But these things are not very concrete. These things are in little early stages of what we started doing. As usual, the real work is done by some other people. I only talk about it. So the people who have done the real work is Vivek Singh, who finished his PhD and is now at Media Labs at MIT. Mingyan Gao, she also finished her PhD and she is now at Google. And I have Siripen Pongpaitset and Lale Jalali, who are still very actively working on this project. So these are the people. The problem that we started thinking about and we wanted to solve is one of the most fundamental problems. How do we connect people to resources? And in trying to do this, you have to consider the three very important factors. How do we connect people to resources effectively, efficiently, and promptly in given situations? As we go forward, I will explain this slightly more details. These things are extremely relevant for building new kind of social systems. We are all going through that, starting from social networks to all kind of systems that we are seeing nowadays are emerging. And we continue to be designing these systems. So the issue that starts becoming is, when we start looking at this, what are the important things that are happening? To me, the first and the most important thing is happening is that now social observations are possible. Earlier, when social science people tried to study any phenomena, there was enormous amount of latency, there was no data available. Now, enormous volumes of data is being available, is becoming increasingly available, and importantly, there is very little latency now there. So that's one very important thing. Because of the first thing, now we can start using feedback in social systems. We can start designing systems that will have feedback. And that has very significant those things available. From our perspective as computer scientists and researchers in certain areas, it appears that in order to connect people to required resources, one of the most important thing is situation recognition. Because in any given situation, you want to connect correct people to correct resources. How do we identify who really needs what kind of resources and where are those resources available? This can only happen in given situations. So that is becoming the important thing, and much of the thing that we will discuss today is going to be related to the third point, what we have started doing this. Everybody talks about big data nowadays, so this is obligatory slide that I need to put. These are the three important aspects. I will not worry about the volume. Everybody knows there is a lot of volume coming in. But the other two important aspects that are very important from really utilizing big data are variety and velocity. And this is where our focus is going to be. Okay. As you will see, This becomes the most important thing. Now, one of the things that we are trying to do is to solve some real world problems, because when we are talking about connecting people to resources, these things are all happening in the real world, in physical world. And when we are trying to do this, the most important thing becomes how do we model the world. There are three important things that happen in the real world that we need to consider. Number one, data. That's why we are worrying about these problems, because we start collecting data from different sources and start using this. But what do we do with data is to find out what are the objects in this. And many of you who have been working in multimedia or computer vision and all these kind of things have always been worrying about object recognition and things like that. The next thing that becomes equally important is what are the events taking place and what are the relationships in different objects and how they are evolving. This is a very important thing to consider, because when you think about modeling the real world, as you possibly remember, when you started learning mechanics, you started learning statics and dynamics. So when Newton was trying to come up with principles of mechanics, he realized that in order to model the world, you have to deal with statics and dynamics, which are very closely related, but they are not the same thing. By the same token, when you are dealing with computer science, they are objects and events. They are very closely related. They cannot exist without each other, but they are different. They are fundamental characteristics that have to be considered and that have to be modeled. And so far in computer science, we have dealt a lot with objects. We have not learned how to deal with events as effectively. So a long time ago, we started dealing with events and started trying to see how do we deal with events. Okay? And in that thing, the first thing that we need to realize is the type of event that we are going to discuss today for solving this particular problem. They take place in the real world. Okay? And these events are being captured using different sensory mechanisms. This is very important point, because in multimedia, when we are trying to deal with, or with all these devices that we nowadays start using, these devices that are bringing us to the real world, there are many different types of sensors. They are all trying to capture the real world. None of the sensors, whether it is camera, whether it's microphone, whether it's GPS or any other sensor, none of the sensor really captures the event completely. It only captures some aspect of the event. So the information that's being captured by any sensor is incomplete. It's in many cases right information, but very incomplete information. So in order to capture the event completely, you have to capture this event from multiple sources and you have to combine those things. So if you think that you can analyze what's happening in this room using only video stream, you are wrong. You can never do that. You have to capture a lot of other information sources, and then only you can do that. So this is a very important thing, and that's why when you start considering events, one has to realize that events create context, and that's a very, very important aspect, because you want to connect people to things, you want to connect people to places at particular time, what kind of data is coming, how one event is related to other event, and all these kind of things. So that means when you start considering this, for representing an event, you have to consider these 6 facets very carefully. And these 6 facets are time, location, but then informational aspect. This is what in computer science we always like to do, that extract the information, who is the person, what is the relationship between different things when this particular event takes place, and so on. But in addition to that, experiential aspect becomes extremely important. Under experiential aspect, as I mentioned to you, you have different sensors. Each sensor is giving you partial information. at one time, we wanted to get rid of the signal as early as possible. We wanted to process it and throw it away because we didn't have memory to store it. But now storage is dirt cheap. You start storing everything. So follow that philosophy. Just start storing all the experiential data, all kind of sensory data that is coming in. And from this data, depending on the different requirements, you start extracting this informational aspects of this thing. The other things are how events are related to each other and what could have caused this information. This is mostly dealt by ontology and knowing more information about this. Causality is the most difficult thing to extract. Okay? So, effectively, when we start considering this, we all know we have been designing lots of very complex systems like this. And we are now talking about one of the most complex systems that you can think of. And you may be surprised at my saying, but this is one of the most complex systems that people are trying to design, because this is going to work in real world with different types of people under different conditions. How do we deal with this? When you start analyzing either this system or this system is very simple environment, not very complex, very simple environment. And this is extremely complex environment. When you start thinking about designing these systems, the most simple thing that you learned at one time is this principle, that all these things use real-time feedback. And feedback is the reason why these systems can work. Okay? So what happens in these systems? Very simple principles. Okay? The simple principle is you always know what is the desired response by the system. But in order to accomplish this desired response, you are always monitoring what is happening at this particular moment. And this is being considered here. You generate the error signal, what is the discrepancy between the two things, and based on this, because you have the model and you understand this, you have the actions that are designed to be applied based on this error signal. They are applied. There could be noise coming in, all kind of disturbances, but these things can be handled very easily because of the feedback mechanism, because at every moment this is happening. So that has been the reason we have been able to design extremely complex systems. Okay? And we can go further and keep designing these complex systems. When we start thinking about this, there are three key factors in this. You have to know what is the desired state. Then you have to have system model and the control signals, and finally you have to know the current state for applying feedback. Okay? And based on these things, we can start designing this. I can get into what are the detailed implications of this, but that will not be of great interest to this particular group. But the important thing to remember is that signals could be very noisy, anything could be, all kind of uncertainty could be there, but these systems work for one simple reason, and that is this mechanism of knowing where you want to go and knowing where you are. This is the simple first principle in AI that I studied when I took my first course in AI. But we always forget about that. We get fascinated by all other simple components. We forget that this principle of knowing where you are and where you want to go, taking the difference between those two, applying appropriate rules to get where you are, we always forget. So the important thing is, now that we always talk about this big data and data is all available, that means effectively we start talking that this can be done now. Earlier, this could not be done. Of course, whenever you are designing a system, if you don't know what this is, then you are wasting your time and all the resources. You have to know this. You have to have ideas about this kind of things. The biggest problem that has been always there is this particular loop. So the issue is, how do we go there? There's all kind of data available now, and when you have the data, there's always this very interesting problem. depending on what is your background, which field you are applying, your techniques, people did consider that you always go through a 3-step cycle. In many communities, they call it observe, recognize, and act. What is happening is that you first observe the data. Based on observations or based on the data that you are seeing, you apply different recognition techniques, and then based on that, you perform some action. Most of the time, we in multimedia or computer vision have been dealing with observe and recognize, all kind of recognition techniques. And if we complete this cycle and come here, then we start generating knowledge. This is what part of machine learning techniques are starting to do this. When you are given big data, you want to recognize objects, but you can now start recognizing situations. And that's what we will be talking about. And in terms of action, you can not only do the planning, but you can start doing real-time control. And when we start talking about real-time control, then we start thinking, can we really apply these engineering principles to social systems? Is it possible to do that? And I started thinking a few years ago that it's worth trying. We may fail, but it's worth trying to see what could be done and what could not be done. And that's what we are trying to do. One of the things that all of us are familiar with are social networks. Okay? And social networks started being designed and became so popular only for one simple reason. What social networks do is, basically social networks connect people. Okay? You can have different types of social networks which are symmetric or asymmetric. Facebook is a symmetric network. In order for me to be your friend, you have to accept me as a friend. Or it could be asymmetric network like Twitter, where I can follow you, but you don't have to follow me. Okay? So all this kind of relationship, you can design different conditions there, and you can put together different types of networks. But the question is, are these things meeting everybody's requirement? What kind of things are needed? So when you start looking at this, you look at the Maslow's hierarchy. Most of you may have heard about Maslow's hierarchy, because this is one of the most famous things from the social sciences, that for every human being, you have these different levels, starting from the basic needs that are food, security, sex, and things like that, to accomplishing self-actualization or nirvana. Okay? So these are the different steps that you go through. You start thinking, for human beings, all these things are essential. We have developed social networks. Where do they fit in? So you start looking at that, and you find that social networks really deal with the top 3 levels. They help you with your ego. They help you with love and belongingness. And of course, if you do the job right, possibly you will start going towards doing some exciting things. But they don't do anything for the lowest level, lowest 2 levels. So much of the social sciences, though they sometimes address these issues, but these are the most important issues for human beings. Can we start applying some things that will help us do this kind of thing? And for that, you start thinking that now in the world, we have all kind of things available. We have web, and we are feeding information from all kind of sources. Okay? Starting from satellite collecting data to all Internet of Things, like putting sensors in all the devices, including on us in terms of mobile phones and things like that. You can start considering all kind of applications that are going in the mobile phones. And these applications that you put on the phone and you use are extremely important. How many of you have used a system called WAGE? W-A-G-E. Anybody use this system? No? Have you heard of this system? No? Oh my gosh, what's going on in this part of the world? WAGE is a company that started in Israel, and just a 15 days ago, it was acquired by Google for more than $1 billion. It is a real-time traffic system.
Oh, yeah.
It is pure crowdsourcing based traffic system. It tells you exactly what will be the speed, what is the condition of the road. I cannot live without it. Whenever I am driving, I have to have the system on. And in fact, it becomes very interesting because initially my wife will say, you are always crazy with these gizmos. But now as soon as I get in the car, she will say, turn on your Waze. Because it will tell me at what speed the traffic is moving for the next 5 miles or anything. It will tell me if there is an accident, if accident is there, in which particular lane is the accident, if there is a particular object there, or a police waiting with a speed trap. All this kind of information. And it is done basically as soon as I turn on my phone, system starts collecting information from me and aggregate this information. But we'll come to that later on. Okay. So all these kind of things are happening in social media. We are collecting all these kind of things. So these are all different kinds of sensors. They are all feeding into the web. Can we use these sensors and start designing something that we started calling, rightly or wrongly, social life networks? The basic idea behind social life network is what we discussed. Can we connect people to real world resources effectively, efficiently and promptly in given situations? That means what we want to do is we want to design this kind of things. That there are people, they are trying to get information, people are of different kinds, there are government agencies that could be feeding information there. Can we detect different types of situations based on this and start connecting people? There could be experts that could be feeding into this. So can we create a network which had not only the sensing devices, but all these kind of things there? And if we want to do this, what do we need to do? What we need to do is, for this, we had to collect all the information from all kind of sensors that is coming in. After aggregating that thing, we have to detect the situation and then send the information there. So what I'm going to be talking is what is really required into this, and these two are the most important steps. Aggregation and composition, collecting information from all kind of sensors. All are heterogeneous sensors. Collect all this information. How do we detect situation from here? And then these things are easy. They have been done by social network people, so I will not touch those things there. So as multimedia or computer vision researchers, if most of you are in that area, we have to understand what is the interesting things going on. So when you start looking at this, we have been dealing with pattern recognition or object recognition and all this kind of things for quite some time. And when you start looking at this, you start looking at something very interesting, that you can consider that there are these two important aspects, time and space. If time is changing, then you say that there is a dynamic thing. So video is dynamic. If you are looking only at a picture, it's static. The similar thing you can start considering, is the system location unaware or location aware? You start considering whether you are going to be dealing with only one medium there. So is the data text or images or video? So in the last century, we mostly dealt with this kind of situation, that we wanted to deal with objects in photos. Okay. If you wanted to have multiple objects in the same photo, you started calling it scene classification or scene recognition. You start even calling it concept recognition in images. If you have the video, then you start trying to detect visual events. And if you are location aware, then you start finding out trajectories, how the objects are moving and things like that. So this is what we have been doing in concept recognition. When you start looking at the history of these things, this is what it started. You started initially with object because you had only pictures. It was difficult to even store a picture. Then you went to the scene recognition. Slowly you started going to the trajectory event. And first time somebody talked about situation was Dickmans when he was trying to design these autonomous cars. Okay? But after just mentioning the term, nobody did any research in that area for quite some time. this sensory, when we started looking at this situation, things changed. Now we are dealing with heterogeneous media, all kind of sensors. GPS, your accelerometer, to your temperature, to all kind of sensors are coming in. You have literally millions of types of different sensors. And when you start considering this kind of things, then you find that the type of thing that you will have to start recognizing are these things. Either you start talking about real world objects. You are not only talking about how this particular object looks in pictures. You are talking about the real object like this. So you will start talking about its characteristics in all other forms. And the same way you start considering all these kind of things. So effectively you start talking about what are the real world objects, what kind of environments exist there, what are the activities, and finally when you start considering this, how situations are evolving. Okay? One very important thing that we start recognizing when we are dealing with this kind of data, that every kind of data is data. When we start talking about data and metadata, we are introducing a caste system in the data. Don't do that. Every kind of data is data. In some situation, one kind of data becomes important. In other situation, other kind of data becomes important. Okay? So you consider that, and then based on that, you start trying to analyze the things. So the first thing that starts coming to mind is that if we are going to talk about situations, as I said, will be important, what is situation? You can go through many different definitions and all this kind of thing. Vivek, while doing research in this, compiled something like 50 different definitions of situations that people are using in real fields different way. And he abstracted those things to come up with this definition that we started calling computational definition of situation. And that is basically an actionable abstraction. So you want to take some action. Okay? So the situation should be defined because you want to have a particular action. It should be based on observed data. So you have some data. The data is spatiotemporal related. So you have to consider time and space very importantly. So if you can do this, then you say that you are starting to do situations. The type of situations that you start considering could be very simple, like somebody suffering from allergy. So today is a very bad day for allergy type of thing. So for allergy and asthma, and we developed application for that. So you will see that. There could be flood. There could be different types of, and the flood could be increasing, decreasing, could be really bad, and you could be stuck in that situation. How do you deal with that? I will show you an application that we built for this kind of thing. Traffic applications. I mentioned wage system. Somebody in our lab is trying to explore some applications toward this. So when we start considering this situation, this is how you start finding out. Let's skip this and go to a simple example. Okay. Suppose that you know that there is a person shouting. That's an event. Okay. You can start considering this. At a particular location, at a particular time, a person is shouting. But if you find that there are 1,000 people distributed somewhere and they are shouting. Now, if these 1,000 people are all over the world, if you consider next 10 minutes and you count how many people are shouting and they are distributed all across the world, you will say nothing is happening. But if all these 1,000 people are in building 99, then you know something is happening. That could be good, that could be bad. But you know that there is something happening. So effectively what starts happening is that you start aggregating these events in space and time. And if you can start doing this, then you start finding out what kind of events could be happening. Same thing can happen here, that one person is complaining about flu, nothing big deal. This person is suffering from flu. But if 1,000 people or lots of people start complaining about flu in Bellevue, there is some epidemic going on here. Okay? So effectively, what you start doing is that you start considering that there is massive streams of data at all locations that are coming in. And you want to try to analyze those. You want to detect events in individual streams From those individual streams, you want to start combining heterogeneous streams and detect what kind of events are going on in real world. And then from there, you want to start detecting situations. And this is very interesting now because, as you know, there are billions of disparate kinds of sensors that are being placed everywhere. If nothing else, you are carrying this phone, and this phone has number of sensors. And those number of sensors is continuously increasing. People are putting all kind of sensors in these kind of things. How many of you have started using this kind of devices? See, at least one person is there. So there are crazy people like me who are putting on 1, 2, and 3 devices. There. So the wearable computing and all these devices are also increasing. So effectively what's happening is that you are going to start collecting data from different sources of different kinds. And it has very serious implications, because each sensor detects some basic events. So the important thing becomes is how do we combine these micro events and make them useful? Because when I showed you these 3 sensors on me, in fact, each of these has multiple sensors. So between these 3, there are at least 10 sensors that are there. In each sensor, there are micro events that could be detected. How do I start doing something with this? How do we do the following thing, that in place of putting a video, and this video camera trying to determine very detailed thing, who is walking and who left the bag there and all this kind of thing. That's good, that's important. But equally important is, can it detect some simple micro events? And that is, a blob in this thing was moving left, or a blob in this thing was moving right, and things like that. So it can start detecting those micro events. And if you start doing this, very important things emerge. This is showing a camera in a surveillance camera that is put in very close to my office there, and this shows the activity that's going on. You can very clearly see the days in this thing, at what time people are coming, what time people are going, etc., etc. So you can start putting all these kind of things which are purely based on this. This is not the first time that we are talking about this. Going from micro events to situations has been a very popular area. So, for example, in case of economics, 2005 Nobel Prize was given for analyzing micro motives and macro behavior. And we all know thermodynamics. Thermodynamics has been used to understand particle behavior, and from there how do you go to the bigger behavior and so on. So this kind of things have been going on all the time. So coming back to our thing, when you want to start detecting situations, there are 2 types of data you will be dealing with. I will not discuss all those things, but basically static data, that is kind of fixed thing, that this particular room is there, this is the structure of the room, this is how tables and chairs are laid out, and these sensors are here, and all this kind of thing. But then this dynamic data. Could be related to type of diseases, could be related coming from Twitter, etc., could be coming from different sensors, could be coming from mobile phones, and things like that. So you start considering this kind of data. So when you start considering this, you have to consider something very important, that from here, all this data is being collected, and we want to design a system that will use feedback to do this. So what kind of actions have to be taken? If we want to understand this, the most important thing is to consider what is the social structure. In human society, we have different kinds of organizations. Each organization can have multiple people in these things. That means ultimately this person, if I want to take some particular actions here, really there are 2 ways to do this. There could be a top-down approach. In this case, it appears bottom-up, but the top-down approach where society decides and makes some rules, or we can provide feedback to individuals. That will be a kind of bottom-up approach. So you start changing behavior of each person, or you start telling each person to take particular actions. Okay? And you have to combine both these approaches in order to do this kind of thing. When we try to do these systems, what are the two important computational problems? The first thing becomes data ingestion. Data is coming from different sources. These sources are very, very different. Temperature measurements may be available on the room basis or on the county basis or on the country basis or whatever. Pressure measurements could be available at entirely different resolutions. They could be coming at different time intervals and all this kind of thing. How do we do that? Equally important becomes is stream processing engine. As I mentioned, there are literally billions of these streams that are being generated. They are continuously coming. How do we analyze those and try to do something meaningful with those so that we can start doing situation recognition? And this situation recognition, unlike the earlier databases, if you go back to your database knowledge, you find that originally in databases, the idea was that data is sitting in the storage and somebody is asking a query and you are getting the answer. The current multimedia system, current video systems are all like that. The video has been collected and then you say, I want to find out this thing. So you go and analyze, look at the data and get the result. But about 10, 15 years ago, in database also, they started thinking about stream processing. They started thinking about continuous data, where the model is completely different. Now you assume that in the first case, in the old databases, data was fixed and the query was coming. The queries were changing. Now what you start doing is change the problem completely. You say, my queries are fixed. I want to know whenever flood is going to be here. I want to know whenever allergy situation is bad. And so your queries are fixed, but the data is continuously changing. Data is coming and going. So you are dealing with the streams. Okay? And as soon as you start considering this aspect becomes very different. Okay? So we started looking at that. The other very important thing that starts happening is that here, now you have to start considering that this term STT, S stands for space, time, and theme. You are collecting information. For example, I have been saying flood or I have been saying allergy. Let's consider allergy. For allergy, there is no sensor that will tell you that today is a very high allergy environment or bad day for asthma people. But there are sensors that will measure different kinds of pollens. There are sensors that will measure different kinds of pollutions. There are sensors that will measure how active I am, that will measure where I am. Okay? Now, all this information has to be collected from here. And this information is coming from different types of sources. So, effectively, I consider a particular location at a particular time. And for particular application, I have to select these different sources and decide which source is going to contribute information, combine that, and use that thing. So effectively, this is what starts happening, that I have this situation there. So I have all this kind of different things happening in the world. I consider a particular location. I have all these sensors, and for these sensors, I collect the information that is represented as a particular point here. When I do it for all the things, I start converting this image to this. Now, once I have this situation there, then I can start converting it to feedback loop. I have the goal, and I can start sending these signals. Okay? This is what the system has to be there. When I am trying to do this, another thing that I need to do is I have to consider each individual, because as we will see in a minute, the actions depend on each individual. So I have to consider each individual, and again for the individuals, I have to consider similar kind of sources. So when we start designing these frameworks, basically, without going into details, these are the three important things. Number one, how do we model the situations? Based on this, how do we recognize the situations? You will see a direct parallel with all the things that you have been doing in any kind of data understanding. You have to have models. whether you get these models through learning or somebody specifies those models. Once you have those models, then you develop the recognition techniques, and once you have the recognition, then you can start taking the actions. Okay? So these are the things. What do we do? Basically, how do we start collecting and recognizing situations globally, and how do we start applying this at the local level? So effectively, in a second, you will start seeing that you start combining information from multiple sources to find out what is happening at the country level. And now, when an individual comes, you look at the individual situation, where the individual is, what is the behavior of the individual, combine these and define the rules and take the actions. So in order to do this, how do we start representing this data? Luckily for us, if you have been working in computer vision or video, one very important thing is we are using a very good representation, because the grid representation, don't think about the image representation, but the grid representation represents the real world. Whether it is two-dimensional grid or you can go to three-dimensional grid. You can consider grid at different resolution level and so on. But that's why people have started putting all kind of what they call thermal representations or temperature maps or heat maps or whatever term you start using. This starts happening. So you can come up with the representation of these things. The first experiment that we did was very interesting. It was purely based only on Twitter, and that's what convinced us that we can do a lot of these things. What we did was, 3 years ago, we started collecting the tweets, and we collected, this is showing from June 2nd to June 13th, density of tweets from different part of the country. As you start looking at this, you see that there is some activity. The activity keeps on increasing, and it becomes the maximum here on June 8th, and then it starts going down. Yeah. So you immediately know that there was something happening, and something happened on this particular day. What was happened was that iPhone 4 was announced that day. So everybody's anticipation is building up, and then slowly this starts decaying. Yeah. So you can say, okay, this is good. That's what Twitter is doing through trend analytics and all this kind of thing. You can do something very interesting from here. Okay. What you can do is the following thing. This is what those tweets are on different days. I can start aggregating those tweets, and I can start representing all over the country this map, that how much interest in which part of the country is there for iPhones. Now I had represented this. Here I know where the retail stores are. These retail stores, I can consider, they call it store catchment area. That means this store can serve in its vicinity this many people. Okay. So you consider that, do the convolution of this, and this represents the given stores can serve this kind of people. You take the difference between these two things and you say this is underserved interest areas. Okay. Now if this is the case and you know the store catchment area formulas, you can decide where you need to put the new stores. Okay. So effectively, in order to put the new stores, you could be just monitoring these things, and based on the current knowledge of this thing, you can immediately decide that this can be done. Now this was for iPhone. We are using the similar principles for deciding where should we put the new shelters when Sandy storm comes in, or when earthquake hits at some particular place, etc. Because principle is exactly the same. Okay? So this is what starts happening. That means what we start doing is, effectively the idea becomes that you have raw data streams coming in, you start converting them to this STT data, and then you start combining those things and start representing the application oriented, or what we call thematic maps. And from those thematic maps, then you apply the situation recognition techniques and classify those things. Okay. So this is, if you go back and you will see that this step to this step is exactly same as you have been doing in computer vision, etc. The earlier steps are because we have heterogeneous data, you have to map the data, convert the data into unified format and things like that. But now we start considering what kind of operations are required. And you start analyzing and you find that there are different types of operations. And these are, some of the operations are purely database type of operations, some of them are purely computer vision type operations. We have used a lot of OpenCV operations in this particular case. But once you have that, you can come up with this kind of rules. So based on this, in fact, Ming and Gao came up with the idea that we should implement something called EventShop. And the reason that she insisted that we call it EventShop is because it's a very funny reason. Photoshop, as you all know, gives you an environment to analyze photos, apply different kind of image processing operations to do particular tasks and come up with the final results. Okay? You don't have to know what those operators really do. You never say that I'm going to use this Gaussian filtering with this support size, etc. You start saying I'm going to do blurring, or I'm going to use magic wand, and all this kind of thing. So effectively, when you start applying those kind of things, you don't have to have any knowledge of image processing. And because Photoshop was done in my lab by Tom Knoll, who was my student, Ming said that if we can use the same principles and apply it to detecting events, combining the events and give an environment in which people can come and start defining different types of events, that will be wonderful. So with that goal, and with the fact that now there are lots and lots of different data sources, can we provide environment for selecting and combining appropriate sources to detect different kinds of situations? And can we develop prediction operations for different kind of proactive actions? And this would be useful for decision makers as well as individuals. So with that, this is the architecture that was put in there, that there is a front-end GUI, there is data web observability, so all the data is coming from there. You can have different techniques for visualization or for forming the models and all this kind of things. Combine these are the different data streams that are coming in, and effectively you come up with this thing, and this image, which is the situation image, will be used by different people to combine and do different operations. This is showing details which we don't have time to get into this, but just there. This is how the interface starts looking like. So this is the EventShop environment. You can go and select different types of data streams that are coming in. So this is the data stream selection mechanisms. You can start using these operators, that list of operators that I showed you. You can combine those operators. You can form intermediate results. And based on those intermediate results, you can form finally your final queries that you want to register, so that now these data streams will be feeding in and the system will be continuously detecting those queries. You can start, as we will see in a second, start doing visualization of those things, and you can start defining the rules. So the first application that we implemented in a very simple demo form, we haven't completed that solution, we are still working on that, was for asthma type thing. And in this, effectively, if you will start seeing, this is pulling the data from one source, scaling that, this is the other source, this is the third source, and this is the Twitter type source. So these are all the sources that are taken, the results are combined using different operators, and this starts giving you the map. Green is a good area, yellow is the okay area for people who are suffering from allergy and asthma, and red is the bad area. You can start defining the rules now for these people. That means if you are in this particular area and you suffer from these things, you should take this action or not take this action, type of thing. And this information we started giving through Twitter at that particular time when we implemented this about 2 years ago. Soon we are now modifying this application, and we are putting app in Android, so that if you have allergy or asthma problems, you will go to that. In place of Twitter, because we believe that Twitter is a very bad source of information for this kind of application. That application that you will have on your phone will provide the information and the system will automatically send you the result. Same thing we did for Thai flood. When Siripan, who is the person working on this project, when she started working on this project, just at that time the bad floods came in Thailand. So she said, why can't I apply this system to Thai floods? And that's what she did. So you take the Twitter data, you take the level from flood data, you find out where the shelters are and what is their situation, and you start combining those things. They are different operators that were applied, and when you execute this, this is what the system starts coming in, that showed where the situation was at any particular time, and based on that thing, you start defining the action rules, and these action rules were that if you are at this particular point and flood level is increasing, you should immediately contact particular shelter. If you are at a place where nothing is happening, you should be told that don't take any action and so on. Okay? So this is what did, and this we implement a system in which the system will intercept any tweets from people that I am here, and it will respond back to the person that you go to this particular location. What we found very increasing was that we never advertised this system or nothing, but the tweets that people were receiving from our system automatically were being retweeted by people. So they were finding it useful. We implemented a version of this for Sandy also when came in. And this whole thing took less than 3 hours to implement the system. So this is the kind of things we started doing. But then we realized that in most cases, you look at a particular user who will be using some particular application, and based on this, the system will go and the result comes in there. But different users have different requirements. Okay? So you have users that have very different requirements, and all of them should not be given the same recommendation. They require to be given different recommendation. So for that, Lale is implementing now a system that looks at your mobile phone, collects all the data, and tries to identify your persona. That means effectively it's collecting the information by asking you some questions, but also by collecting all the sensory information from there. And based on that, it is trying to build the complete persona so that when your system is looking for help, or as soon as you run the application, this thing gets connected to the EventShop. EventShop immediately looks at you, try to decide what kind of person you are, and when it is trying to recommend an action, it's trying to take that particular thing also there. That means effectively there is this general situation and there is this personal situation, and those two things are being combined. We are in the very early stage of this work. The first application that we have decided, and that's why when I showed you these sensors, is for health reasons, so for allergy, asthma, etc. Because if I am an allergy patient and I am very active, then the system should tell me whether I should be active today or I should not be active. If I want to remain active, if I want to go outside, what actions I should take, what medication I should take, and all this kind of thing. So for that, this information comes from this kind of system. So this is what we are doing. The current status of the system is, you can see the live EventShop demos at this particular place. The system is currently password based and things like that, but within next 2 months we are going to release the open source version, so anybody can start using the system. Because we found that in Sri Lanka some people are using this for agriculture purposes. They are using this system, and from Japan, organization called NIC, National Institute for Communication Technology, they are building this project, Cyber Physical Cloud Computing project. They collect lots and lots of data. And after the last earthquake, they are very interested in building a system that will guide people during that particular time. So they started working with us. They have a very big team of researchers which is working with us, and we are trying to develop how their event warehouse combines with our stream processing engine. And this EventShop is being used there. A company from India took the responsibility, luckily for us, to develop the open source EventShop, because my students are interested in getting degree, not in developing open source software. Good for a student, but if we want to advance this area, we need to do this. So luckily this company is doing this, and they are the one who told me we have made good progress. Soon we'll release this version there. So what did I want to communicate to you today was that now social observations are possible with very little latency, as I mentioned in the beginning. It is now possible to design social systems with feedback. Okay. Situation recognition is a very interesting topic, very interesting research area, and a lot of things to be done there. This will give us need and availability, and that's what can be there. So we have started looking at this EventShop as the first step in this direction towards implementing this. That's all we are doing. So thank you very much for your time and attention.
Thank you, Ramesh, for very insightful, inspiring talk. So we can take probably a few quick questions.
So can I ask you, Ramesh? I find the situation very interesting when you define spatial temporal. In the past, people always talk about event at different scale, and also talk about abnormal event.
That's right.
So is that appropriate to say situation is abnormal large-scale events?
Abnormal is a wrong term there, okay? But otherwise, situation is aggregation of lots of events. Okay. They could be classified into different things, and some situations will be abnormal. Yeah. And that's where you want to start taking particular kinds of action. But you want to be monitoring all kinds of situations that are evolving.
Okay.
Yeah.
So it's an aggregation.
That's right. So when you start aggregating events from all kinds of sources, you are starting to identify situations. Now, some situations you don't have to do any action. Some situations take place rarely. Yeah. And one of the things, you indirectly refer to a particular point that is extremely important. When I first started working on this, many of my friends said, you are working on disaster response, because I gave you the example of flood. That was one of the early things. My reaction was, no, that's not true. Because consider that Apple example or iPhone example. That's not the abnormal situation. That's not disaster response. Or allergy type things are happening almost every day. I want to find out as much as that it's a good day for me, as much as I want to find out that it's going to be a bad day for me. Yeah. And another very important thing that I realized, and that's why I did not want to focus on disasters, is that during the time of disaster, if you develop systems that work only during disasters, most people don't know how to use them. They don't know even about those systems, so they are rarely used. On the other hand, the systems that are commonly used, people are very familiar with this. So Twitter, Facebook, and these things are very commonly used during the time of disaster now. Yes, sir.
So one observation I had was that in your allergy example, you showed this allergy heat map.
Right.
The hotspots correspond with large population areas. It seems unlikely that those are the only places where people are.
In fact, your observation is.
Due to allergies, right? So
Yeah.
it seems like it's a kind of a fundamental crowdsourcing problem that you only detect stuff where you have a lot
So,
of activity and a lot of input. I mean, is there, how do you
In fact, okay, the question was that in the allergy example, the areas, the heat map that I showed the bad allergy areas only where there is large population. Yeah. And that observation is very good observation. The reason was one of the 4 sources was the Twitter. If we remove Twitter, then the maps will be very different. So for example, if we go back very quickly to, oops, why is this not going back? If you go back to the other things, pollen count and pollution levels and this kind of thing, you will find that pollen-based things are for all the areas. Now, pollution level is also currently little bit related to the urban areas, because we will measure pollution more precisely in urban areas. They are not measuring pollution in Idaho and all those things there. They will be measuring in New York and LA area a lot more. So the data sources that we have used in this step are biased towards populous area.
Okay, let's thank Ramesh
Yeah.
again, and because of time.
Yeah.
So we'll take a 2-3 minutes of break.